Okay, so during the break, I banned Uncle Carbs completely accidentally, which is hilarious. But he's unbanned now, so those misclicks, hey? We left off, we were busy making some sweet benchmarking from one, and making requests from one API to another, and this slowed our performance, cut our performance in 3, which is not great, so we want to try and find a way to get better at this. So how do we do that? Well, when you think about it, this is going to be a long-running script, and managing all these connections and requests and responses, it's all going to happen in the same process for the most part, unless we have some weird architectural thing going on. And so one way that we could get around this is by using a cache. Now, there is I/O associated with using a cache like Memcache or Redis, which we may want to avoid. But what we can do is store this stuff just in memory, right? If we allocate enough memory for this daemon-like long-running script, then we can store a reasonable amount of stuff just in memory and pull it straight out of an array. That's pretty efficient, I think. So how do we do that? Well, maybe we can do something like cache is an array. This is hilarious if this actually works, but anyway, global cache, and let's just print our cache, because I want to see what this is, right? In fact, I want to see if this is available for writing. So I'll do foo bar, and here I'll do cache bar baz. I want to see if I can write to this in a maintain state, and I have this available to use, right? So let's restart this, and let's make another request to the JSON endpoint. And what do we have in here? Bar baz! We don't have access to the outer thing. It's pretty weird. Okay, what happens if we use this here? If we use this here, and we comment this out, and we restart the server. Okay, that works. So we have reference access to this. Okay, let's delete this. And let's just use this cache array as a kind of global memory store. Why not, right? In fact, we'll keep it close to this function, and we'll just keep this as an array. Now, you probably want to have a nicer API wrapped around this, which, you know, is fine if you want to do it. I don't want to do it right now because it's going to complicate the code that we write, and I want to do something practical. So, let's store something in this. How do we do that? Well, I think what we can do is have something like, you see, what happens if we start the server up and in an uncached state, 100 requests get made to this endpoint, and we have to try and cache this 100 times. We get what's called a cache stampede, which is that every request sees there's no cache in that second, and every request starts getting and generating the cache. And then we have 100 things trying to generate the cache, and then the bottleneck doesn't become requests to uncached data, it becomes our memory server, like our processing, our memory consumption just falling over, and if it's memcache falling over, or database access thrashing, which is not what we want, right? What we want to have is something to say, okay, let's do something like requester or master. Let's call this master. Call this null, and we'll use this as well. So cache and master. Now, if we don't have cache for this, let's just say if not is set, in fact, let's say if is set cache JSON. And we'll give this kind of a unique key for this endpoint. So you probably want to find, you probably want to find more interesting keys to give this thing. But anyway, if cache JSON is sent, then just return a new response with that, with cache JSON. And we'll make sure that a stream is stored in here. So we can do something like that. Okay? If that cache is there, just do this. That seems reasonable. Alternatively, we have to now start generating this. So how do we do that? Well, we don't want to have 100 requests try and make this HTTP request to the external service all at once, because that's inefficient. We just need one to do it and everything else to wait. So we could put the wait somewhere else, or we could say something like if not master, then do this whole request thing. Okay, we could do that. So, in fact, maybe what we do, let's put this elsewhere as well. Let's make this the worst case, is that it'll run this stuff. But here we'll say, if master, then we can say something like periodic, and let's import this. Cache stand here. Let's use this. And then we just have to say loop periodic. Now what are the arguments for this? I forget. Interval, callable. Okay, so we can say the interval is 0.1 seconds. This is going to make a lot of memory overhead for these things. I mean, we can even make this, we can make this more if we want. How long do we want subsequent requests to wait? Here we'll use cache again. In fact, I'm just thinking about a very effective way to do this. Use cache and master again. Well, do we want to do that? No, we just use cache. Okay. How do we do this though? How do we do this? I can't remember how these docs work exactly. So get Icicle. I just want to see what this periodic returns. If you're able to yield it to return the promise that it returns or something. Examples. Do we have anything here? No. I guess I could just go and look at the implementation, right? So return loop timer. Okay, this returns an instance of the timer interface. So this is not exactly something that we want to do, but we can do something like data is null. And then use that as a reference, and then we can say if is set cache JSON, again with that same key, then data is JSON. Yeah, I mean, I guess. And then if data, then yield this. That's another thing. Oh, that's super messy. For some reason, this inspection can't see that I'm passing in a variable here, and that I'm writing to it. Oh, cache JSON. That's actually what I wanted. Will this fix? Oh, never mind. Okay, maybe we can do something like this. So this is going to fire off once every 0.2 of a second, and if there's a cache there, then set the data to that. And only once we have data here, well, I mean, this doesn't do exactly what we want, right? This doesn't do exactly what we want. I'm confused now. We do want to check if there is some data cached, if there is a stream cached, and if that's the case, we just yield that stream. But I don't know what to do about the stampede. I don't know how to delay these things. Periodic is going to add something to the event loop. So that's how we can do the frequent checking, but how do we get from there, how do we get the data from there into yielding a response? Maybe we have to use a deferred. Maybe we have to use a deferred. Okay, I'll comment this stuff out here. Now, I've not used deferreds before, so this should be another interesting example. That source will be in examples. Coroutine. I mean, or we can do something like this, I guess. So yield promise resolve. Okay. So we still have our periodic here because we've got to check if that data is cached, right? But then we can say something like yield, can we? Promise is new. Promise? New deferred. I really wish I had the docs for this. I think it's Icicle promise deferred. I think that's what it is. Still with me? The loop doesn't end, Mr. Squirrel. The loop doesn't end. Okay, so it is promise deferred. Okay. So use Icicle promise deferred. And then we have new deferred, and then over here we say we've got to use this deferred, of course. Okay, we say deferred resolve cache JSON. Okay, let's check every 0.2 of a second. If there is a cached value, then deferred resolve. Then we can do data is yield deferred. Whoa, if that works, if this works, hey, yield a new response. I'll be very excited if this works. I may just jump up and down a little bit. Okay, we can get rid of that. Let's see if that works. Okay, so if there is a master request already to work the stuff out, then just wait until it works the stuff out. That seems fine. In all other cases, we make the new client, we get this data, and then it's a bird, no, it's a plane, no, it's super cute. You had to defer. Okay. We yield stream end, and then we say cache JSON is stream 2. Because that's just what we return straight away, right? Let's try this horrible abomination and see if it works. Root. JSON. Whoa. I hate to say it, but I think that might actually be working. In fact, let's make sure it's working by saying in here, print value is cached. And this can say waiting for value. And this can say finally got value. Oops. Finally got value. And this can say getting value. Getting value. Alright. Let's restart the server because I'm super curious to see if this actually works. Okay. First request, getting value. Second request, getting value. Third request, getting value. Okay, so that's not working so well. Maybe what we can say is cache JSON, master, in fact, we'll say something here like master is request. We are using master, right? Yes, we are using master. So master is request. And then after all of this stuff happens, we can say request is new request, yield yield response. Sorry, this is actually response. Here we can set master to null. Okay. I want to see this cache in action. I want to see it. I've got to see it. So terminal says getting value, getting value, getting value. It's not storing this for some reason. That pretty much sucks. Print our cache. Well, it has the memory sink that's ended. That's pretty weird. If is set cache JSON, then do that stuff. And if there's master, then wait for that value. Otherwise, get value. So down here, we should have that value already cached. Pretty weird. Pretty weird. Maybe we just do return here. Just to make sure, or we do, let's do else if, and let's do else here, just to make sure that only one of these things run for each request. Because maybe it's running all three of those things. We can drop the return out of here. Oops, what did I even do? Okay, getting value, getting value, getting value. It's just running the else every time. That kind of sucks. Okay, let's call this null, and let's say if not cache. Just make this really, really simple. So there's no getting confused about what's going on. Resolve cache. Cache is stream 2. Master is null. Getting value. Flip, I can't figure it out. Anyone from chat know what I'm doing wrong? Let's try to do that. Although I might get a pass by reference error. Nope. Value is cached. Of course, it doesn't return anything, but it's doing the right thing now. So cache is stream 2. In fact, I even want to change this to caching false, because I don't need to store that request, right? Caching true, else if caching. Caching, oops, sure. Nope, that's not actually what I want to change. Cache is null, caching is false. Whoops, undefined variable master. Caching. Okay, getting value. Value is cached. 3 times! 3 times it said this to me. Value is cache. Of course, it didn't even say cache, but anyway. 3 times it said that to me. What's that about? Of course, it doesn't actually return the cache. Maybe what we should do is here print what that cache is, just to make sure. Okay. Getting value. Value is cached, and it's the memory sink with data hello world. And again, value is cached. For some reason, it's requesting this 3 times, which is pretty weird. That's pretty weird, but why doesn't it yield this then? Yield response 200. Maybe we just put this right at the end. It does look like I'm getting the value. And I'll change this back to stream. For each of these, I'll just say cache is stream 2, stream is stream 2. Caching is false. Yield new response to stream. I'll just do that. over here I'll say stream? That doesn't seem right. I actually have to put this into a memory sink. I have to say something like stream is, well, no, it's already a memory stream. Sorry, never mind. Never mind. Okay, because I'm trying to cut down on the amount of responses I have to generate. So the first time, getting value. Second time, a big old error, get length on unknown. And that is, I assume, over here. Oh. Stream is cached. Oops. Okay, getting value. Big old error again. Get length on null. Line 72. Well, what's down here? The stream is cache. One day I'll get there. Getting value. Value is cached. But again, no response received. That's pretty weird. And to be honest, I don't know why. I don't know why I'm getting that. Because I write that directly to cache. Cache is stream 2. I mean, maybe what I need to do is create the memory sink with data. Maybe I need to say stream is new memory sink yield stream end data. And then I just cache the data. Maybe that's what I do. Cache is that. Cache is empty. I can remove these outer brackets because PHP 7. I don't need to end the stream here. I can just say caching false. In fact, I'll move this up here to say cache is empty string. Caching false. Okay. So, I'll just say this, if caching, if not cache and caching, or if cache is empty. Cache is empty and caching. Then wait for the value, else get the value. And else if cache is 0, then get the value. And then just take cache from here. Delete that. Okay. This is getting interesting. So if cache, then cache is yield deferred, or just yield deferred. Well, no, just yield deferred is fine. Should be fine. Oh, this is so exciting. But we get nothing now. What am I doing wrong? Stream end. Okay. Nothing. Print our cache. Cache is blank. Cache is blank. This doesn't seem to be happy. Do I need to use brackets here again? Why? I shouldn't need to. In fact, I shouldn't need to do that. It is caching, it gets this data, and then caching is false. Tweet! Oh my gosh, all the windows. Let's empty all of this because I think I've now done something wrong to this cache. Just remove all cache and see. Okay. It's getting this stuff. It keeps on rewriting to cache because this keeps getting executed. Cache, so cache is blank. Let's restart this and run it again. So it just keeps on nuking that cache value with the new value. Okay, that's fine. So if cache is empty, oh, damn it. Damn it! And not caching, okay. Cache is empty and not caching, then run this stuff. If cache is empty and it is caching, defer until it has a cache value. If cache is empty and not caching, then get that cache value, like generate it, otherwise just return it. This seems like it should work to me. Alas not. Okay. I'll figure this out soon, everyone. I'll figure this out soon. If not, caching. If caching. Do this stuff. This is just a Boolean logic problem that I'm having, and I'm feeling too thick to get it. Thanks, Greg. Waiting for value, getting value. Gets it. Interesting. It doesn't say getting value anymore because cache isn't empty. It's just returning it straight from the buffer. What happens if we do something more intense with this? What if we do some concurrency? Let's just do very low, because if something goes wrong, I don't want this to blow up my whole server. Finally got value. Good grief. Did this actually work? Waiting for value. Finally got value. I think that's it. I think it's working like we want it to work. I think it's working like we want it to work. Whoa. Okay, so a cold server start and some Apache bench. And let's do 100 concurrency and 150,000 requests. And let's see how much this takes, how long this takes. Now this is kind of cheaty, and I'll tell you why this is kind of cheaty. We're only hanging the first dozen or so requests until we get a response from that server. And then everything resolves, and we start serving cache all the time. We've gone even higher than we were before, presumably because something in my system is let go. But we're doing 700 requests per second, and most of them resolve almost as quick as before we did the client requests. Which makes sense, because it's only hanging the first few, and the rest is serving with cache. And if you look at this code, it's actually super clean. It's super clean. There's a bit of overhead, okay, which we could probably clean up a little bit. But look what we're doing here. This is the interesting part. We're making a new deferred, and we're checking on the event loop for something in the shared state to resolve. And once it is, we resolve the deferred. And then we just yield. We just wait until that deferred is done. So this periodic will keep going until it resolves. And we can have some kind of timeout in there to say, okay, if you've tried this 20 times, deferred, reject. And then that yield will happen. We'll have to trap that error somehow and deal with it. But this is pretty cool. We can start making requests against the GitHub API, for example. Okay, let's do this. Let's restart the server. Let's do this. Wow, something blew up there. let's check this out though. The GitHub API sends headers to say how many you still have. This is my rate limit per hour. This is how many I have left, 48. I'm making thousands of requests, but it's only made one against the GitHub API from this invocation. So this is really cool. If you have to connect to a third-party service, you can do it using a similar method to this without running over bandwidth limits, without having your server stampeded. This performance is a little bit slower, and that's, I presume, because it is getting more data that it has to put in the sink. I presume that's what it is. And if you think about it, maybe we don't have to construct the memory sink every time. Maybe we can have a shared memory sink that has the response for this. Maybe that's what the level of cache is. And that's what I try to do, but obviously that didn't work too well. Anyway. This is pretty cool. I'm super excited about this. I was going to do some interesting generator stuff, but I'll tell you what I will do. Okay, we've gone down quite far, and I think it's because we're making so many memory sinks. I think that's the problem there. So that's something to look at. There is one trick which I want to show you, and this is a really fun trick, but we can't really fit this into our server right now. And it's something that Sam thought of earlier, which is pretty cool. So I'll call this generators. Okay. So there's this thing where you have a number of interfaces in PHP called a number of implementers of an interface called iterator. And basically what this is it's a way to implement things that look and feel like arrays but are custom data types. So things you make, but that you can use in a PHP loop. Now, one way to work these things out, one way to make these things. Let me get chat back up here in case I'm missing questions or something. One way to do these things is to say class my array thing implements iterator. Iterator, that's it. Iterator. But then we have to implement a bunch of methods. Current, next, key, valid, and rewind. Okay? That's not really that fun if we have to do this over and over again. Alternatively, wow, I just really messed up there. Alternatively, once we've deleted all this stuff, we can say class my array thing implements iterator aggregate. And this just needs one method. It is getIterator. But now we can start doing other interesting things, like we can say return new array iterator and give this an array of 1, 2, 3. Sure, something like this, right? I'll delete this comment and I'll say thing is new my array thing for each thing as value. Print value. And when we run this back in here, woohoo, PHP generators, 1, 2, 3. Simple so far? Following? Okay. This is how we make something that looks and feels like an array but isn't. So a custom class with our own methods. We can, for instance, have something like public function hello, print hello. So we can use this like an array, but then we can also do other things in this class. We can say thing hello. And when we run this, 1, 2, 3, hello. Okay, now, we've been doing a lot of generator stuff, both in Iris and in Icicle, and generators form a huge part of what those things are. But did you know that we can use iterator aggregate to make our own generator? And use that in an array-like fashion. I mean, we can already do something like make a function that yields a value. Hi, Nickrox. We can already do something like a function that yields a value and that becomes a generator. But this also supports generators. getIterator and iterator aggregate support generators. So we can have for 0, I, 3, I++, yield, I. We don't have to return. We don't have to return an iterator, an implementer of traversable, an implementer of iterator, an implementer of iterator aggregate. We can just return a generator. So we can start doing lazy load values as iterator aggregates, which is pretty fun. I think it's pretty fun. Anyway, this was a neat trick that Sam showed me today. I thought it was fun and I'd share it with you. But as I said when we started, this is a shorter stream. I kind of have other writing stuff that I want to do now. So I think it was kind of fun. We got to maybe like backtrack a little bit on the Icicle work and figure out why things were maybe going slow or why we were benchmarking incorrectly on it last time. And I'm more encouraged to do stuff with Icicle again. Even though I think based on the examples I had last week it wasn't performing very well, I'm excited to do real world stuff. So I'll pick up the real world stuff again. And I will... yeah, I'll do some more Icicle stuff next week and some more Arrow stuff, surely, because I'm having a lot of fun with those. So please do come back. Yeah, please do come back and watch the stream if the stuff interests you. I have a lot of fun doing it, really, which is why I do it. But I'm going to go now. So have an awesome weekend and take it easy and do some fun code and tell the world about it, because